Standard command line tools work fine for standard AI agents, but when you need to deploy a highly customized runtime to Amazon Bedrock, you have to break out of the standard AgentCore CLI boundaries. We are going to bypass those default limits. By the end of the setup, you will have packaged a custom FastAPI server inside a Docker container and deployed it directly to AWS. To build this bridge to AWS, you need 3 tools installed locally: the AWS CLI for cloud access, Docker BuildX for multi-architecture compilation, and the Python Package Manager, UV. Start by creating a new directory for your project. Then open your terminal and initialize it by running uv init-python-3.11. Next, add the required dependencies. You'll run the uv add command for FastAPI, Invoking, Pydantic, and the Strands Agents package. Using UV instead of older Python package managers automatically generates a locked uv.lock file. This creates a completely deterministic environment, ensuring the dependencies that work on your laptop will behave exactly the same way in the cloud. Bedrock doesn't care how you write your internal logic, but it does enforce a strict agent contract. For your custom runtime to function, you have to follow specific architectural rules. Rule 1. Expose a /ping get endpoint for Bedrock's continuous health checks. Rule 2. N/invocations post endpoint. Here, your app routes the JSON payload to your AI and returns the response. Rule 3. Your server must listen exactly on port 8080. With the agent.py script written, run the Invoking server locally. Open a second terminal window and execute a test curl command directed at your localhost ping endpoint. Your terminal should immediately return a JSON dictionary reading status healthy. Meeting these endpoint requirements guarantees that when we push this code to AWS, Amazon Bedrock can monitor the container and pass prompts to your AI logic without timing out. With the local server running successfully, we have to package it into a Docker image. This step contains the most common failure point for custom deployments. Amazon Bedrock AgentCore exclusively accepts ARM64 architecture. A standard container built for Intel or AMD will immediately fail in the cloud. To enforce this, we start our Docker file with a specific from command, explicitly locking our base image to Linux/ARM64. The rest of the Docker file handles the standard workflow. We copy our UV dependency locks, sync the packages, import the agent.py script, and expose port 8080. Because your local computer might not run natively on ARM architecture, you use the Docker BuildX command in your terminal to compile the image for the target platform. Forcing the architecture at the compilation stage acts as an absolute safeguard. It guarantees your container matches Bedrock's cloud environment, avoiding architecture mismatch errors entirely. Our architecture is locked. Now, that local Docker image must be moved to the AWS Elastic Container Registry, or ECR. In your terminal, use the AWS CLI to create a new ECR repository. Then, pipe your authentication token into the Docker client so you have permission to push the image. This is a stylized look at the final push command. Before you hit enter, you must replace the placeholder account ID string in the URI with your actual AWS account number. Now we deploy. Create a script named deployagent.py. This uses the Bodo3 library to execute the create agent runtime operation inside AWS. The deployment script requires 2 non-negotiable parameters: the agent runtime artifact, which points to the ECR image you just uploaded, and a valid IAM role ARN that grants the necessary cloud permissions. Run the script using UV. A successful execution bridges the gap, transforming your dormant container image into a live, queryable Bedrock AI entity. To verify the connection, write a short invoke agent.cli script and send a test prompt, like asking the agent to explain machine learning, to your newly deployed runtime. This JSON layout shows the successful response payload. You can see the specific assistance reply text formatted correctly, along with a generated timestamp confirming the real-time execution. With the success confirmed, we have to talk about resource containment. Active live agent sessions continuously accumulate financial costs by the minute. AgentCore does feature a default 15-minute idle timeout. However, executing a manual termination is the strict best practice for immediate and reliable cost control. Create one final script called stop_runtime_session.py. Execute it in your terminal to proactively kill the active connection and shut the runtime down. Mastering this manual lifecycle management proves you have absolute control. You built a custom AI environment locally, pushed it through the cloud barrier, and managed the exact infrastructure it runs on.